Hello everyone. From today we will start the practical topics of electronics. Okay. Today's topic is regulated power supply or the series regulated power supply by using two transistor and a Zener diode. Here Zener diode act as a reference voltage. Here you can see in the circuit the output voltage is 12 volt. Okay. So that means this circuit will give us the 12 volt steady state output, or this circuit is for the 12 volt power supply. Okay. So here you can see if we change the input voltage from 14 volt to 40 volt, then also we can see that the output voltage is 13.2. That means it's changed a little bit. Okay. If I change to 20 volt, then you can see that it will be around 12.6 volt. Okay. So that means if I change the input voltage from the 12 volt to 20 volt or 40 volt, the output voltage is changed very little. Okay. That means the line regulation is very good, right? I already have some video on the load regulation, line regulation for the Zener diode, where I already told you line regulation mean where other all the parameter is same, we will change only the input voltage and we will check the output voltage. So for this circuit you can see the line regulation is very good. Okay. Even if I want to check the load regulation, that means we need to increase the load current. Okay. How we can increase the load current? We can increase the load current by changing the output resistance. Now you can see 1K, right? If I change to 2K, then you can see that the output voltage is around 12.6 volt, right? If I change to 5K, then also output voltage you can see is 12.6 volt. That means if I change the output resistance, that means if I change the load current, then also the output voltage is consistent. That means it's the same, right? And if I decrease the load resistance, or that means if I increase the load current, then you can see that it decreases a little bit. Okay, so that means for this circuit the load regulation is very good. Okay, so I will explain the load regulation, line regulation in the latter part of the video, where I will show you what you need to do for this practical in your examination. Okay, now you can see there is so many resistance like 330 ohm, 1K, transistor, right? 1K pot, 5.6, 6.8, many resistances there, right? So I will show you how to calculate the values of the resistance. Okay, and in the examination they will told you create a power supply or design a power supply of a 12 volt, okay, 12 volt DC and maybe 100 milliampere current, okay, where you need to use a transistor 2N3055, okay, that is a power transistor. I will tell you why we need to use a power transistor, and a BC547 or a CL100 or SL100, okay, and the reference generator voltage will be 6.2 volt. Okay, with this kind of thing you need to design a power supply which will give you a 12 volt output. Okay, here you can see I didn't connect the rectifier part. Okay, that one I will explain in the theoretical part. Okay, I just here assume that we have a DC voltage source, okay, where I can change the DC voltage such that we can change the output voltage is changed or not. Okay, but in your practical what you need to do, you need to change the voltage. In your practical you need to use this circuit, okay, where you can see that we have a bridge rectifier circuit with a capacitor as a filter. Okay, so this particular part, the left hand side of this circuit will act as a rectifier with a filter, okay, where the AC voltage will convert it to the DC one. Okay, and that DC will be regulated by this particular RPS circuit, and in the output we will get a 12 volt DC output voltage. Okay, so let's go to the pen and paper, and I will explain you how this circuit will work as a regulated power supply. Okay, and how to calculate the values of this resistance, and how to check the circuit in your exam. And also I will design the circuit in the breadboard. Okay, so let's go to the pen and paper. So today we need to make a regulated power supply, right, by using a transistor and a Zener diode. I already show you in the simulation that the output voltage is consistently around 12 to 13 volt when we change the input voltage from 12 to 40 volt, right? And also I to show you that if I change the load current, then the output voltage will also constant. Okay, so you already know that this is the basic block diagram of the power supply, right? Regular power supply. Here you can see we have a transformer. I already explained you all of these blocks in the half wave rectifier video, right? For this regulated power supply, I will explain you again. Transformer. Why we need transformer? As in our home we have a power supply of 230 volt 50 Hz, right? And here for the load we need around 10 to 24 volt DC, right? So for this one, what we need to do? We need to decrease this voltage from 230 to around 24 volt. That means we need a transformer which will decrease the voltage from 230 volt to 24 volt. Okay, that's why we need a power supply. Now, why we need a rectifier? We need a rectifier as this power supply is the AC, right? The home power supply is the AC and our load is the DC. So we need a device such that that device will convert the AC to the DC. That will convert by the rectifier. But the rectifier will convert this AC to a pulsating DC. That means that will looks like a half sine wave, right? This is a pulsating DC. So we need another device called filter. What filter will do? Filter will eliminate this pulsating DC to the pure DC. Okay, eliminate these ripples and make it to a pure DC. Okay, and then we need a voltage regulator. Why we need a voltage regulator? I already have a video on the loading effect, but I already show you that if the power supply input resistance is a non-zero, then what will happen? Then the output voltage V0 will completely depend upon the load resistance value, right? That means if we change the load resistance, then what will happen? The output voltage will also change. It will not fixed, right? And also if we change the input voltage, then also output voltage will change. That's why we need a voltage regulator such that if we change the input voltage a little bit or the output current a little bit, the voltage should be constant. Okay, so I already explained all of this thing in my previous videos. Okay, so now today we need to build a power supply with a transistor as a Zener diode. Okay, so here is the circuit. This is the circuit of our voltage regulator. Okay, here you can see this one is the transformer, right? And we give the output voltage here of the transformer. That means this output voltage is already stepped down to around 24 volt. Okay, in this circuit I didn't show you the transformer image. Okay, now the rectifier part. Here this part is the rectifier. Okay, so this one is a rectifier. Okay, now the filter. This is the filter. Okay, and now the voltage regulator. This whole part is the voltage regulator. Okay, and then the load, right? And this is the load. Okay, so I think you can relate this circuit with the block diagram. Okay, now I will explain you the principle of this circuit operation. So now let's understand the control system behind this regulated power supply circuit. Okay, here you can see we have the unregulated input voltage Vin as the input. Okay, and this input will go to the control element and the output is here, and we write down regulated output. Okay, suppose the output voltage is increased. Okay, and here we have the sampling circuit which will take the sample of the output voltage here and give this voltage to the comparator circuit as a feedback signal. Okay, and here this comparator circuit will compare the sampling voltage with the reference voltage. Here in our circuit the reference voltage is the Zener. Okay, then it will compare the Zener voltage with the sampling voltage and create a error signal. This error signal will goes to the control element. Then this control element will decide that whether we should decrease the output voltage or increase the output voltage. Okay, that means suppose the output voltage is increased, that means the sampling voltage will increase. Then the sampling voltage will feed back to the comparator circuit. Here we have a reference generated voltage. Okay, if the feedback signal increase, that means the error signal will increase. Okay, that means the control element will understand the output voltage is increased. Okay, at that time what it will do? It will decrease the output voltage and it will make it constant. Okay, and suppose the output voltage is decreased, it will act as the same way and it will increase the output voltage. The control element will do the work like this. Okay, so now we will see that how this particular circuit will act in our regulated power supply circuit. Okay. So here you can see I just draw the control system and the circuit just top and bottom, right? Now you can see here we have the control element, right? Here this is the control element Q1. So control element is the Q1 in this particular circuit. Okay. Here you can see sampling circuit. What is sampling circuit? This is the sampling circuit. R and the R2. This portion will be the sampling circuit where this circuit will sample this circuit here. Okay, here you can see the reference voltage. Here the reference voltage is Vz. Okay, here you can see comparator circuit. This Q2 will act as a comparator circuit, and this comparator circuit will tell this control element, or this comparator circuit will send the control signal to this control element Q1. Okay, and here you can see the unregulated input is this one is the unregulated input. Okay, and V out is the this one. So I think you can compare this particular two circuit and you can say that which one is the control element, which one is the sampling circuit, which one is the comparator circuit, right? Now let's forget about this portion, right? This portion will only do the AC to DC part, right? We need to understand only the regulated power supply circuit, which is this one. Okay. Now let's go to the circuit. So you can see here, I deleted the input part and deleted the output load circuit part. Okay. Now you can see this is the solely the regulated power supply circuit. Okay. So we need to understand how this circuit will work. Okay. So here, this is the output voltage V0. Okay. And if we assume this current is I, then we can write down V0 is equal to I into R1 plus R2. Okay, and we assume that the minimum current required to make the output voltage 12 volt is I equal to 1 milliampere. Just assume this one. Okay, and then here I neglect the R pot resistance. Okay, as this pot resistance we use to make or calibrate the output voltage. Okay, so we don't need to consider this R resistance, and here this R resistance will be around 1k, so you don't need to consider. And we can write down VR2 will be V0 multiplied by R2 by R1 plus R2. Okay. Here you can see in the circuit this voltage is VBE and this voltage is VZ, right? We can write down VZ plus VBE equal to VR2. Why? If I apply the KVL in this particular circuit, then this voltage is VR2 and polarity is plus minus, right? So minus plus minus plus, that means same polarity, right? That means VZ plus VB, and plus minus, that means opposite polarity. So VR2 equal to VR2, right? And this current is IB2, as this is Q2 transistor. This current is IC2, right? This current is IB1 and this current will be IE1. Okay, and we assume that this current is I. Okay, so now we can write down, if I apply KCL at X point, then I equal to IB1 plus IC2, right? And IE1 is equal to alpha multiplied by IB1, where alpha is a constant, right? So let's assume V0 increased. Okay. If V0 increased, then what will happen? Due to the sampling circuit, what will happen? VR2 will increase. Okay. Now, if VR2 will increase, then what will happen? VB will increase. Why? As VZ is constant, right? We all know that if the voltage across the Zener diode is more than the Zener voltage, then the output voltage of Zener diode will be constant, right? So VZ is constant. Due to that one, VB will increase to make the equation okay, right? If VB will increase, then what will happen? We all know from the input characteristic of transistor, if this is VB and this is IB, then what will happen? VB to IB characteristics looks like this. That means if VB will increase, then IB will increase, right? Here you can see this is VB2, right? If VB2 increase, then what will happen? IB2 will increase, right? If IB2 will increase, we all know that IC2 will be beta into IB2, right? That means if IB2 increase, then what will happen? IC2 will increase, right? That means here IC2 will increase. As a result, IB1 will be decreased as the total current should be constant. Okay, so IC2 increase, IB1 will be decrease. If IB1 decrease, then what will happen? IE1 will be decrease, right? If IE1 will decrease, then this current I will be decrease. As a result, what will happen? The total voltage will be decrease, right? So you can understand how this circuit will work and how the whole control system will work, right? That means you can understand this is the sampling circuit, this is the comparator circuit, this is the reference voltage, right? And this one is the control element, which is ultimately controlling the IE1 current, and that current will control the whole output voltage. Okay, now let's see if the V0 decreased, then what will happen? Suppose V0 decreased, then what will happen? If V0 decreased, then VR2 will decrease. If VR2 will decrease, then VB2 will decrease. From this output characteristics, if VB2 will decrease, then what will happen? IB2 will decrease. If IB2 will decrease, then what will happen? IC2 will decrease, right? If IC2 will decrease, then IB1 will increase. If IB1 will increase, then what will happen? IE1 will increase. And if IE1 increase, then what will happen? I will increase. And if I will increase, then V0 will increase. That means when the voltage is trying to decrease, then this whole circuit will make the output voltage increase and make it constant, right? And when the output voltage increased, then what will happen? Then whole circuit change the it particular currents and voltage and make the output voltage decrease, so such that the output voltage will be kept constant. You understand? That means this circuit will act as a regulated power supply, and this is the concept of it. Okay, now let's do the calculation of this particular resistance, and I will show you how to calculate the resistance. Okay, in the examination they will give you this generator will be 6.2 volt, 0.25 watt. Okay, that means the VZ is 6.2 volt, P is 0.25 watt. That means I max will be 40 milliampere. Okay. Now we need to calculate the value of source resistance. Okay. Here in the input voltage we will take maximum of V input will be 20 volt. Okay. So V input max we consider is around 20 volt. That means when we will do this practical, at that time we will increase the V in maximum of 20 volt, not more than that. Okay. So V input max is 20 volt. So we need to calculate the RS. How we will calculate the RS? RS will be V input max minus VZ divided by I max. Okay, or IZ max. Okay, so here V in max is 20, VZ is 6.2 volt, I max is around 40 milliampere, right? That means this will equal to 13.8 divided by 40, right? And if I do this calculation, then we will get around 330 ohm. Okay, so we already got the value of RS is 330 ohm. Okay, now I already told you in this calculation that we need at least 1 milliampere from this circuit to make the output voltage 12 volt, right? That means V0 is equal to I into R1 plus R2, right? That means V0 is equal to 1 into R1 plus R2 into 10 to the power minus 3. Here we are making V0 12 volt, right? That means this will be 12 into 10 to the power 3 equal to R1 plus R2. That equal to R1 and R2, the sum of these two resistance should be equal to 12 kilo ohm. Okay, and we have one more equation, that is Vz plus Vbe equal to Vr2, right? VZ is 6.2 volt plus VB is 0.7 volt, right? That means VR2 will be equal to 6.9 volt. And VR2 equal to, we know that VR2 is equal to R2 by R1 plus R2 into V0, right? That means 12 into R2 by R1 plus R2 is equal to 6.9 volt, right? That means 12 R2 equal to 6.9 R1 plus 6.9 R2, okay? So if I take this one this side, then 5.1 R2 equal to 6.9 R1, okay? So R2 will be equal to 6.9 by 5.1 into R1. So R2 will be 1.35 into R1. So if I take these two equation, then we can write down R2 equal to 1.35 R1 is first equation, and second one is the R1 plus R2 is equal to, we have 12K, right? So if I just put this value equation 2 to the equation 1, then we can write down that 1.35 R1 plus R1 equal to 12, right? That means R1 will be equal to 5.1K and R2 will be equal to 6.9K, right? But when we will do this practical, at that time we need to use the practical resistance, right? In the market, we didn't get 5.1 or 6.9, right? So to adjust this one, we need a potentiometer, and we will try to take the resistance close to these two values, okay? Here we can take 5.6 kilo ohm and here we can take 6.8 kilo ohm. Okay, we can take this to resistance such that our circuit will act as a regular power supply of 12 volt. Okay, so here this will be 5.6K, this will be 6.8K, this will be 1K pot, and we already get this one 330 ohm. Okay, and in general case, every time for the collector resistance, we always take RC equal to 1K. Okay, that is completely fine. As if we calculate this RC resistance, it will be around 1.33K. Okay, so we need to use the 1K. So in general, you don't need to calculate that one. You just write down in general RC is always around 1K. Okay, so if I use 1K, then this circuit will be okay, right? So we already got the values of this all resistance, right? R is equal to 330 ohm, RC is 1K, right? R1 is 5.6K, R2 is 6.8K. Okay, so if I take this resistance to the simulation circuit, then we can build the regular power supply of 12 volt. Okay, now the next thing is the load regulation, line regulation. Okay, so now I will tell you in the practical what you need to do. Okay, so first, this all what I told you is just for your Viva question, and for the calculation is for your practical. Okay, but you need to do the practical in the exam hall, and you need to show to the examiner that the output voltage is around 12 volt with the input voltage around 20 volt, right? So what you need to do first, you will provide a RPS kit, or you need to do this rectifier in the breadboard. Okay, so when you get the question at that time, they will provide you the VZ value and the power rating of this VZ. Okay, and they will told you to make a 12 volt 100 milliampere power supply. Okay, so at that time I already show you how to do the calculation. Okay, so first need to do the calculation, and you need to tell your examiner that you need this all resistance 330 ohm for RS, RC is around 1K, R1 equal to 5.6, R2 equal to 6.8, and you need a pot of 1 kilo ohm. Okay, and for the transistor you need Q2, SL100 or CL100. Okay, or you can get BC547. Okay, and Q1 you will need 2N3055 transistor. Okay, I will explain you why we need a power transistor for this one. So you will get this particular resistance from your examiner. Then you need to build this circuit. Okay. After you build this circuit, you need to check the output voltage is how much, right? Before that, I want to tell you that don't do the whole circuit at the same time. What you need to do, divide the circuit like this. Okay. So first you need to do this particular circuit of filter or the rectifier, okay? And after that, you to check the output voltage is how much, and you can use a CRO to check the output voltage is really DC or not. Okay, this will be the first thing. Then you to start this particular circuit. So for this circuit, you need to make this one first. Don't build the whole circuit at the same time. Okay, so this will be the part 2. Okay, so this is part 1. This will be part 2. And I think you already know how to build the generator circuit, right? So you need to build the generator circuit. And after that, you need to make sure this output voltage here, this one should be 6.2 volt with the input voltage of 20 volt. Okay? If this one 6.2 volt, then you will start the rest of the circuit. Okay? Now you need to start the connect this particular transistor to transistor. Okay, then connect the RC and let's see the output voltage is how much. Okay, you should get the output voltage around 12.5 or 11.5 like this. Okay, when you get the output voltage like this, what you need to do? You need to change the resistance R or the 1K pot to swing that one and make that voltage around 12 volt. When this voltage you need to set around 14 volt. Okay, so you need to set the voltage 14 volt here with the change of here the input voltage, and then make the output voltage 12 volt by changing this pot resistance R. Okay, so your circuit is perfectly okay if you make this kind of thing. Okay, suppose you build this circuit at a whole at the same time, and you need to find out, and you find out that the output voltage is not 12 volt. What you need to do? You need to check three things. First, check this voltage VZ, this one. Check this too. Okay, this is the reference voltage, right? And this is the main part of this particular circuit, so it should be working. And if this VZ is okay, then you should get 6.2 volt. Okay, in general case, many of the students make this one as a forward bias. That means they connect the generator diode like this one, right? That means you should get here 0.7 volt, right? If this is 0.7 volt, then you will not get here 12 volt. This is the first mistake many students did in the examination. Okay, so first thing is the check the biasing of this generator diode such that this reference voltage should be 6.2 volt. Okay, this is the first thing you have to check. Suppose you check this one and you saw that you get 6.2 volt here. Okay, don't worry, I will tell you the second step. Second step, you need to check this transistor potential VB. Okay, if this transistor is fine, then you should get here 0.7 volt around. As if the transistor is working fine, then the voltage around VB voltage will be 0.7 volt, right? Suppose you get 0.7 volt here, and then you get here not 12 volt, then what is the problem? The problem is this pot. In my experience, in most of the cases, the problem will be in the potentiometer, as this is the moving object. Okay, the potentiometer you need to do the swing, right? And this is a moving object. So most of the time potentiometer is the faulty one, and due to this faulty potentiometer, what is happening? There is some open circuit, so you will not get the actual output voltage as these two resistance is disconnected, right? So there will be no current flow from here, so you will not get the output voltage in this particular circuit. Okay, so first thing you need to check the VZ or the generator diode. Second, you need to check this transistor by checking the VB, and third, you need to check this potentiometer. How we can check this potentiometer? As in the potentiometer there is three terms. One is this resistance R, this one, and this three, and there will be another arm 2. Okay, so how you to do? You need to set your multimeter in the resistance mode, okay, and just connect in this 2. Okay, so if you change this knob to this side or this side, you can see that this multimeter should show you the resistance is changed. Okay, so you need to check this to terminal 2 and terminal 3, and then if this 2 is okay, then connect the multimeter to terminal 1 and terminal 2. Then do the same thing. You should check this thing and you will get the resistance will change in the multimeter. Okay, If you saw that by swinging this potentiometer, you will get the resistance varying these two terminals, that means this potentiometer okay. If not, then you need to change the potentiometer, okay? And most of the case, potentiometer is the faulty one, okay? So by this kind of thing, you can check your circuit, and I will tell you this is the most important things for your circuit to do the troubleshooting, okay? Suppose something is wrong and your professor is coming to your desk and see this kind of thing, like how you do your troubleshooting, then they will give you the full marks. As if you know how to do the troubleshooting, that means you are really know how this particular circuit works, or you already know that which one is the important part for this particular circuit. So if examiner saw this kind of thing, then you will get the full marks. Okay, so this is for the troubleshooting. And one more thing, please check you should connect all the component in the perfect point, right? Now that means this is a breadboard, okay? Suppose you connect this resistance in this point, okay? And you connect another resistance in this point. So this is not in the same line, right? That means there is already disconnection, right? So how the circuit will work? And this is your fault, right? So make sure all the connection in the breadboard is perfectly fine. Okay. So this is all about the what you need to do after you get your practical paper. Okay. And you need to do the calculation, you need to do the troubleshooting, and you need to make the output voltage 12 volt. Now you already make the output voltage 12 volt, right? So what you need to do? In the next step, you need to do the load regulation and line regulation. Okay. So what is load regulation, line regulation? First, you need to do the line regulation. Line regulation means you can see in the circuit we have three parameters, right? V input voltage that can vary, load current that can vary, and the output voltage, right? Here we need to change these two parameters, V input and load current, and we need to check the output voltage. Okay. For the line regulation, what you need to do? You need to change the V input voltage, and IL should be constant. That means you cannot touch any of the things in this particular circuit. Okay, you can only allow to change the input voltage. Okay, and what you need to do? You need to check the output voltage V0. Okay, so at that time, just plot V0 with change of input voltage. Okay, so what you can see? You can see that this voltage is going linearly up to around 14 volt. Okay, and then if you change the input voltage or furthermore, then what will happen? This voltage will be constant. This will be around 12 volt, and this point and this point can vary maybe from 12 to 12.7 to 12.8 volt. Okay, so this will be the line regulation. How to make the line regulation? You need to change the input voltage by around every 1 volt. Okay, and you change every 1 volt and take the output voltage data. Here you need to connect one AC voltmeter, one DC voltmeter. Okay, and you need to take the table will be like this. Table will be V input, V0 AC, and V0 DC. Okay, I need to do like this 1, 2, dot, 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 up to 20 volt. Okay, then you need to do the graph of V0 DC and V input. Okay, this will be the plot of line regulation. If you do the plot of V0 DC and V0 AC, you will get the ripple factor. Okay, so this will be for the line regulation. Now next is the load regulation. From the name you already understand load regulation, right? That means we need to change the load resistance. Okay, if I change the load resistance RL, then what will happen? Then load current will change. Okay, and what will be our purpose? For the load regulation, V input voltage will be constant around 15 volt to 16 volt. It depends upon you or the examiner. They will tell you in which voltage you need to keep constant the input voltage. Okay, then what you need to do? You need to change the load current IL, and you need to plot the V0 DC. So your table will be like this: load current, V0 DC, V0 AC. Okay, and here you need to increase the load resistance, change this spot, and you need to get the data from 12 milliampere. It will be the first as the 1K maximum, right? So that means 12 volt, 12 milliampere, and up to 200 milliampere. And you need to get the V0 DC and V0 AC. Okay, so you can see that your data will be looks like this one, and this will be around 100 milliampere. That means your voltage regulator will work up to 100 milliampere current. After that one, there will be no voltage regulation as the output voltage will decrease. Okay, so this will be the load regulation. Okay, so you need to do these two things in the practical examination. And another will be the ripple factor. Ripple factor will be around VAC by VDC. Okay, so this all you need to do in the practical. Now let's build the circuit by using the breadboard. So now it's very challenging as I need to do this thing in the iPad. I don't have the actual breadboard or the resistance, but what I try to do, you can see here our RS, this one RS, right? RS is how much? RS is 330 ohm. Okay, so this one is 330, this one is 1K, 5.6, 6.8, 1K, right? And this is the load resistance. Okay, so you can see here I try to take the resistance such that it is 330 ohm. You can see the color code, right? This color code is such that this resistance is 1K, this resistance is 330 ohm. Okay, this is 5.6 and this is 6.8. Okay, what I did, I just tried to take the photo from the internet and try to take the resistance like this such that you will feel it real. Okay, so now let's build the circuit. So you can see here, first is the transformer, right? And here will be plus and minus, right? So this is the plus terminal, this is the minus terminal. Okay, so what you need to do, the plus will go to this terminal. Okay, and the minus will go to this terminal. Okay, so I already connect these 2 points. Now the capacitor is connected to the other two terminal, right? That means this point and this point, right? So what I need to do, I need to connect the capacitor here. Okay, you need to remember when you connect this capacitor, you need to remember that here you can see the plus minus, right? So that means this is the negative terminal, this is the positive terminal. As this is for the AC, you need to remember this one. Okay, so I already connect this one. Now you can see from the capacitor one point, the resistance RC started and RC started, right? That means from the capacitor point is this one, right? That means from this point, we need to connect this wire. Right? So you can understand these 2 points is the same. Okay? Now, from this point, a 330 ohm resistance is connected to a Zener diode, right? You can see this is 330 from the color code, right? How to do the color code? As if this is a resistance, 1 band, 2 band, 3 band, and this is the tolerance band, right? This first digit will be directly go there, second digit will be directly go there, and third digit will go to the 10 to the power. Okay, so you can see this orange mean 3, this orange mean 3, and brown mean 1. That means 3 into 10 to the power 1. That means equal to 330 ohm. Okay, here you can see this resistance is the brown. Brown means the 1, black means 0, and here is the red. Red means 10 to the power 2, right? That means it will be around 1000 ohm or 1K. Okay, by like this we can crack the color code, right? So you can see from 330 ohm I already connected Zener diode, and you can see here this Zener diode, this is the negative terminal and this is the positive terminal, right? Many of the students make it wrong. They just flip the Zener diode and after that they will not get any output voltage. Okay, so this is minus, this is plus. Okay, so I connect this one, and after that you can see this point should be ground, right? So what we need to do, we need to ground this point. Okay, and this point is we need to ground from the outside. Okay, now we already make this up to this part, right? Now we need to connect this transistor. Here we can see I already make the diagram for the 2N3055 transistor. For the 2N3055, you can see that this is the 2N3055 transistor, and for this one, the case, that means this whole body is the collector. Okay, and the you can see that the distance this one and the distance this one is different, right? So from the smaller distance, the left hand side is the base, and from the smaller distance, the right hand side is the emitter. Okay, so what we need to do? We need to connect the collector through the 1 kilo resistance, right? So collector is the whole body, right? So what we need to do? We need to connect a wire to this port, okay, to the body of the collector, to the 1 kilo ohm resistance, right? The starting of the 1 kilo ohm resistance, starting of the 1 kilo ohm resistance is this one, right? So we need to connect like this. Okay. Now we can see the base of the transistor will connect to the another point of the 1 kilo ohm resistance. So base is which point? Base is the, this is base, right? As the, this is the short distance, and the left hand side is the base, like this you can see in this image, right? So this base will connect to the another point with the 1 kilo ohm resistance. Okay. Now for the emitter, what we need to do? We need to connect the emitter with the 5.6K. Here you can see this is 5.6K, right? This resistance is 5.6K. So what we need to do? We need to connect this one, this emitter, to the 5.6K resistance. Okay, done. 2N3055 done. Now let's go to the BC547. Here you can see BC547 transistor. You need to check how, like this. The flat surface you need to make in front, and then this area is 1, 2, 3. 1 will be emitter, 2 will be base. This means this will be E, this will be B, and this will be C. Okay, so you can see here one point, the emitter will connect it to the generator, right? That means this terminal. So we need to connect a point from this one to the emitter, right? To the this one. Okay, emitter is connected. Now the collector will connect to the base of this particular 2N3055, right? So what we need to do? That means just take a wire from the base to collector of this transistor. Okay, now you can see the base is remaining, right? So we need to connect the base to the 1 kilo ohm port, right? And the middle of the 1 kilo ohm port will go to the base, right? So what we need to do? We need to connect this base to the middle of this potentiometer. Okay, and you can see the another 2 point of the potentiometer will go to the 5.6K and 6.8K. That means this point will go to the first point here, 5.6K, and another point will go to the 6.8. Okay, so you already got that one, right? Now what you need to do? You need to connect a load resistance, right? This RL. So RL will be, you need to connect in this particular point here, 5.6, the start of 5.6, and another is the start of this one, right? So this will be RL. This will also will be a potentiometer. Okay, and that terminal should be grounded, right? That means this should be, sorry, this should be grounded. So this whole line should be grounded. Okay, so by this one you can do the circuit. So now you need to do check the output voltage, right? Here I already make the multimeter. So multimeter positive will go to this particular point, and negative will go to this ground. Okay, so this is all about circuit diagram. Okay, so you need to do the circuit like this, and you need to do the circuit by part, just like what I did, and you need to make sure the voltage, right? So what you when you do the circuit diagram, at that time first do up to this one and check the DC is there or not. Okay, then just do this part up to and check the Zener diode is giving you 6.2 volt or not. Okay, after that connect this transistor, okay, and check that you will get the 0.7 volt or not, and after that just check output voltage is 12 volt or not. If not 12 volt, I already told you, check Zener diode, check this transistor, and ultimately check this 1 kilo ohm part. You will get the answer. Okay, so this is all about the regulated power supply circuit. Okay, now let's again go to the simulation, and I will show you that if I change the input voltage, output voltage will not change, and if I change the load current, output voltage will not change. Okay, let's go. You can see that this is the input voltage. First we need to do the line regulation. So what we need to do, we need to increase the input voltage from 14 volt to by step by 15 volt. You can see when I make it 16 volt, what is the voltage is 12.4. Now I make it 18 volt. You can see this is 12.5. Now I make it 20 volt and this is 12.6. That means I change it from the 14 volt to 20 volt, but the output voltage changed from 12 to 12.6 volt. That means it's very normal, right? And now suppose we need to change the current. So now you can see the 1 kilo ohm, that means only 12.6 milliampere. So voltage is 12.6 volt. Change the resistance from 900 ohm. You can see that voltage is 12.6. Decrease to 800 ohm, 12.5. Decrease to 700 ohm. You can see is 12.5. Decrease to 500 ohm, 12.5. Decrease to 200 ohm. Then also you can see that is around 12.4. But if I decrease to 90, then you can see that around 9.68, right? As we make this circuit for the 100 milliampere, when the load current is 108 milliampere, you can see that it will not work as a voltage regulator anymore. Okay, so this is all about the regulated power supply practical. You need to do all of this thing in the practical, and after that one you need to do the plot, and from the plot you need to calculate the load regulation percentage and the line regulation percentage. Okay, now I will provided you the manual for this practical, such that after seeing this video you can read that particular manual in the home and you can just go to the examination. That manual, whatever I say in the video, everything is written down in the manual. So let's check the pin comment and download that manual. Okay, thank you. Bye bye. Thanks for your time. Please do share this concept with your friends. And if you like this video, please press the like button. It is really means a lot for me. Bye bye.